Science and Technology Part 1st, Chapter number 6, Refraction of Light. Now, the next part in this chapter is why stars twinkle at night? That question is there. And now we can see stars are at very large distances. That means in light years. The closest star to our solar system is at a distance of 4.3 light years away, and this distance is a very large distance, and the object which is present at a very large distance makes a very small angle with our eyes. Therefore it appears as a point source of light. This means the amount of light rays coming towards the observer on the surface of the earth is very less. Okay, now as the air in the atmospheric layer is constantly moving, that means the hot air, which is less dense, goes in upward direction, and while the cold air, which is denser one, moves towards the downward direction. Between these phenomena, wind is blowing, due to which the refractive index of the air is constantly changing. Because of this, the light rays passing through the atmosphere change their direction, and therefore at the time when the more amount of light rays reach up to the eyes of the observer, the star appears brighter, and when the light rays which are reaching up to the observer's eyes become less, then it becomes less in brightness. Therefore, the star appears twinkling. Now, the next phenomenon is the apparent position of the star. What is the apparent position of the star? आभासी स्थिती आपण त्याला मराठीमध्ये म्हणूया. The density of air in the atmosphere goes on increasing from higher altitudes to lower altitudes. Okay. Therefore, the refractive index of air also goes increasing towards the surface of the earth as we move from top to down. When light from stars is entering into these layers of the atmosphere, then they enter into the denser medium from the rarer medium. Therefore, the normal at that place is there like this, and to that normal the light rays bend towards the normal. Again, here light rays bend towards the normal. Now, as the observer is seeing these light rays like this, the projected light ray is coming from this place. But this is not the actual position. This is the apparent position. Okay, and therefore actual position of the star is like this, but apparent position is slightly elevated from the real position. This is the phenomenon. Okay, that means when sun is rising, at that time actually it is not the original place, but it is observed at the apparent position. Now next is the dispersion of light. Sir Isaac Newton for the first time passed the white sunlight through a triangular glass prism like this, and then got the bands of 7 different colors like this: violet, indigo, blue, green, yellow, orange, red, like this. And this band of 7 colors is also called as the spectrum of light, and this spectrum of light is of the sunlight. Therefore it is also called as the spectrum of sunlight, ज्याला मराठीमध्ये आपण वर्णपट असं म्हणूया. असा वर्णपट मिळतो, आणि हा 7 रंगांचा वर्णपट जो आहे तो आपल्या सूर्यापासूनच मिळतो. Here you can observe the violet light ray is bent to the most, and red color bends least, and other light rays are bending in between these two. Okay, this is the phenomenon of dispersion of light. Now, the next part is partial and total internal reflection. When light enters into the rarer medium from the denser medium, here consider inverted condition is there. Light is coming from this denser medium, that is here water is shown, and here there is the air. Light is coming from denser medium and entering into the rarer medium. Now it gets partially reflected here, this light ray. Light ray is going in forward direction in air, but some part of that is reflected in the same medium. Okay, now this is called as the partial internal reflection. A part of light ray comes outside the medium, but part of the light ray gets reflected back into the same medium. Therefore it is called as partial internal reflection. And the rest of the light ray gets refracted into the rarer medium. Okay, if light ray is going from denser medium to rarer medium, from denser medium to rarer medium, it goes away from the normal. Okay, that means angle I is smaller than angle R. Angle R is greater, which is made with the normal at that place. If I is increased, suppose I is increased here, if we increase the I, then R also increases according to the Snell's law. Okay, now a certain value of I is there at which the value of R becomes 90 degree. That means the light ray passes along the surface of the denser medium. Okay, and this value of I is called as critical angle. Now beyond this critical angle, that means IC is the critical angle, and we make the angle more than that or greater than that, then what happens is R increases than that of the 90 degree. Therefore, if I becomes larger than the critical angle, R becomes larger than 90 degrees. Such rays return to the denser medium itself totally, not a part. It is totally reflected into the denser medium itself. This phenomenon is called as total internal reflection. And then our next part is the formation of rainbow. This phenomenon is a combined effect of dispersion, refraction, and total internal reflection. What happens actually? See here. In the atmosphere, after a rainfall, there are very small droplets present in the atmospheric layers of the air. And in that droplets, the light ray enters like this. That means behind of the observer, light rays get entry into the droplets. When the light ray enters into the droplet, it gets dispersed and refracted simultaneously like this. When it gets dispersed, red light reaches up to this point and violet light reaches up to this point. And from this surface, that means the interface of the droplet and air, the light ray gets totally internally reflected like this. And again reaching at this point, they again get refracted and they reach up to the observer, and the observer experiences the view of rainbow. Thank you.